Welcome to a lesson with Dr. Powell. Let's take a look at how we can think about a graph and its transformations, how to change it up a little bit. For instance, what if we had the graph of y equals square root of x, which we notice just squared both sides. And this looks like a parabola on its side, and it's actually 1/2 of a parabola because when you solve back, you take a plus minus square root. And notice we only have the plus part. So really we're looking at, let's start with this graph here of a sideways parabola, this one right here, just one half of it. And this is a function, passes the vertical line test. All right, so we're going to look at a transformation of this, how to kind of work with it a little bit. First of all, let's get some points on it, like 1, 1, and 4, 2. And 0, 0 here. Okay, so we have x and y. And this equation is y equals square root of x. Now I want to put a box here and a box here. And I'm going to put a box here and a box here. So we call this like an x box, a y box. And it's kind of an equation of what's happening. So I've kind of made the variables into an x box variable and a y box variable. This is the y box axis and the x box axis. So why did I do that? That's because we're going to throw different things into these boxes. For instance, what if instead of x, we were to just put x plus 1? So now this is a relationship with between y and this x, but it's the same relationship between the boxes that we had before. For instance, look at this point. What if we were to plug in 4 into the square root? So the whole box here is 4. Isn't this whole box still 2? It is. So even if we relabeled what's in the box, the output of the box is still reflected in this graph right here. So if this is 4, then definitely for sure the output of the square root is 2. Now, if we make this axis the x plus 1 axis, then all the points you see, like 4, doesn't represent what x equals, it represents what x plus 1 equals. So we have an x plus 1 equals 4 here. This is an x plus 1 equals 1. This right here is an x plus 1, x plus 1 is equal to 0 right here at this point. So with that, how do we change the picture so we again get an x-axis? Well, we got to do something to all these values. Well, what if we were to subtract 1 from all these values? Okay, so subtract 1, so this is an equality. I'll subtract 1 from both sides. 1, 1, minus 1, minus 1. Notice what we get now. We get x equals 0 right there for this point. This point, we end up getting x equals -1. For this point right here, we end up getting x equals 3, meaning that if we wanted to graph this according to an x-axis, well, why don't we do this as well? Why don't we subtract 1 from this guy right here, -1, and we end up getting x. Then we get an x-axis again. Ooh, so if this were an x-axis, this would be 3. Sorry, that's a 3 now. Okay, this point here would actually be 0. Oh my goodness, so the y-axis would actually be right here. Okay, and this point would be a -1. So we just erased the axis and move it over, and we have just successfully shifted our graph and changed it. Notice that our x plus 1 right here, replacing what was in the box here, created a shift of the whole graph over 1 unit to the left. The idea was, from the square root, what was right next to the square root, like the whole thing under the square root, represented like the old x value on the original graph. Now, our pathway for how to get from x plus 1 to x was to, what did we do? Subtract 1. That means to get to the new x value of x, which is embedded inside of here, we had a pathway from the square root function, or the square root operator right here. So the square root operator. And we want to know, how do we get from here, starting here, hitting the whole expression? What do we need to do to get to that inner x? Well, to unravel that package, we had to subtract 1, which means to all the old x values, we subtracted 1. So all the x values go down by 1 or get shifted to the left. Now, likewise, we could do something similar with y values, and we'll see that in the next video. Thanks for watching.